Hello, everybody. My name is Frank Ober. I'm a principal engineer in Optane Solutions. So we're going to share a use case. We're pivoting from high performance over to the cloud. It's hard to get cloud providers, as you know, especially the super hyperscalers, to share their designs. So we're excited to share this one. This one is VK. And VK stands for VKontakte, which it is Russia's largest property on the internet, period, not just social media property. If you go to Alexa 50, they're right there in the middle as the biggest property on the internet for Russia. And you probably haven't heard of it because it is primarily Russian language, but they claim over 500 million user accounts. As you can see here on the slide, 97 million active users a month. Essentially, it's like WhatsApp. They provide a rich media messenger for most of this user interaction that they support and what the infrastructure supports. They also do what Facebook does in terms of business websites, personal websites, in the traditional thing that got started so long ago. Look at these numbers. These are big numbers. In the case study, which is available publicly in a couple days, they're at 19,000 servers. And so they were doing a refresh of their infrastructure, and they totally bought into the adjacencies and what kind of efficiencies they can achieve by using our adjacent products and bring their compute costs down. Get this, guys, 40%. Let me repeat that. They reduced their compute costs on a like basis, apples to apples, 40%. Huge server reduction and just densification of the platform. And you're going to see architecture pretty soon here. So they wanted to leverage tiering, right? So they have support for data tiering because the lifetime of data in social media is very, very transient, as you can imagine, even if you're not an engineer in that space. They had to figure out ways to re-engineer how they support the data that they support and basically support that pyramid that you saw earlier in the hour in a software sense. And we're going to get into it in just a little bit. So the hottest data sits on Optane SSDs. The less hot data actually goes to our QLC product. I'm not sure if you're familiar, but we have a 15 terabyte QLC product that revolutionizes cost on the SSD. And that's our first gen product. As you can imagine, we're going to be getting into 32 terabyte, 64 terabyte, low cost, but NVMe class SSDs as Intel rolls its roadmap forward. They also in this solution use persistent memory. So I know Kristie's super happy about me talking about that one more time today. And FPGAs are part of the solution as well. So let's take a look at the diagram, and we'll do a little bit of looking at their architectural flow and what their components are about. All right, so this is about supporting, like they said, there's 90 million active users on any given time chatting away. They have a very custom distributed CDN across the Eastern European states that primarily use this solution. And right here, they migrated into containers, and they provide a hot storage container and a warm storage container. And you can see they leverage a small amount of Optane and a very large 15 terabyte containerized storage capability on these nodes. And they got these nodes down, roughly in half. And so with containers, they can spin stuff up. They can elastically control the demand as that happens, because certain times of day are busier than others. And that was the first part. And number two, in their data center core, which is running on bare metal, there too, they're using the same components so that they can have, there's obviously upgraded networking here, probably 100 gigabit. I'm not talking about that. But they have this tiering capability there as well, so they can have the great performance of the hot data and then quickly move older data out to the QLC-based SSDs. Gave them very compelling economics on the core data center servers so that they could reduce the footprint there as well. In terms of video transcoding, they do have to do video transcoding, and this is where the FPGAs with the Optane SSDs come together with the software. we are seeing more and more design patterns also in database where FPGAs are very good. They're very high powered, as you probably know, but they can do specific functions like filtering data, or in this case, video transcoding, and leverage Optane SSD, Optane storage very, very well. This company went ahead and did that, and their transcoding infrastructure is brand new, and it supports far better throughput per server. And then the final use case inside of this VK architecture is maybe something you haven't heard of yet. Memcache you probably have heard of. It's an in-memory KV store, or at least was traditionally a single tier, only DRAM-based KV store. And the guys like Netflix and Facebook, and actually Facebook really introduced Memcache to the world, love it because of session data, right? They can store that transient session data, which has a very short time to live, in these caches that are ripping fast, always under a millisecond, which is usually their requirement. But what VK did is they actually tiered Memcache into persistent memory. Why? Cost. What we're seeing, and this is actually one of Kristie's best domains for making money, is that those people that want 1 terabyte per Memcache or Redis node often buy persistent memory. And why? Because you might only need 100 gig of DRAM and 1 terabyte of persistent memory. We can easily support these 1 millisecond requests of this extremely light software into the network and provide that session state and other session data that the users need. So you can look something up. Memcache has been supporting this for a couple of years now. This tiering, it's called XStore. It's used by some of the top companies. Go ahead.
Something like this would be ideal for SAP HANA and things of that nature. Are you guys working with those guys as well to provide Optane storage?
Oh, yeah, absolutely. They were actually, SAP HANA's probably worked on PMEM, persistent memory, longer than any database vendor for years, Kristie, right? I mean, it goes back to when we were children. And
speak for yourself.
And so, they have a different architecture. Of course, it's an in-memory database, but they store like their catalog and the things that, they still use DRAM buffers for the hottest data in HANA, and they store things like their catalog data, which is voluminous, in persistent memory.
So I was just going to do a quick summary, remind you guys what we talked about. We're really bringing innovation in this space with Optane technologies. We have product flexibility. There's options to use SSD versus persistent memory or both. And we're heavily engaged in the partner ecosystem. And we're really starting to see these examples of real customer value today. And then, looking forward into the future, we're working together with our partners on the Intel platform side, as well as the ecosystem partners. We've already got 4 generations actively either in market or under development today. So lots of exciting things happening in this space. Hope you'll keep us top of mind and follow along on the journey as we move forward. We included one additional slide at the end of this that we'll be sending out to the participants. And this has a lot more information that you might be interested in, the IO 500 that we mentioned, Barcelona Supercompute, some of our customers' websites for these solutions, as well as some Intel places to go and learn more.